So the applied voltage from the power supply, it's going to help move the electrons from the copper electrode to the aluminum key, and then the ions migrate and eventually contact the key, and when they make contact, they accept the electrons and they convert the copper ions into copper atoms that stick to the key.
Melissa, in this reaction, the copper sulfate, the copper from the copper sulfate is going to the key. Is the sulfate going to the copper thing? It's just in solution.
This is then breaking off because the concentration of the copper 2+ is going down. So to keep it constant, the more copper breaks off.
Okay, so for this lab, what we're going to want to have to make sure that we're safe is safety goggles or glasses at all times. The materials that we're using in this lab can be very dangerous and we don't want to get any in our eyes. To protect your skin, you want to be wearing an apron if possible. If not, really be careful about your contact with solution. It's very, very dangerous. To keep your hands protected, if you have rubber gloves, wear them. Any type is going to work. They're going to help you. If solution touches your hands, wash them immediately to get rid of all the solution that's on your hands and to help keep your hands protected and unirritated. If any spills happen, please let your teacher or lab instructor know right away.
You take about 200 mils, 250 mils.
It's supposed to be about 150?
Doesn't matter.
Right.
Copper sulfate. Pour it into this beaker, 250 ml beaker. Place a strip of copper. This is where the copper will be coming from, on the side of the beaker. Then you're going to take copper wire, attach it to a glass rod. This is where you're going to be hanging your key from. And then you take your key and you mass it before, so you can get the mass after as well and see how much copper you got on there. You attach the copper wire to the key. You want as much area of copper touching the key as you can, because that's where you'll be pulling the copper from, and you dip the key into there. You take black to negative, red to positive. The positive end goes on the copper strip on the side of the beaker, and the negative end goes on the copper wire on the glass stir rod. And then you're going to turn it on. Turn up the voltage until you see about 2.5 amps. And you let it sit for half an hour, and the copper should plate onto the key. So this is what the final product looks like. Just a little bit of copper on the key. Alright, so just to finish it off, rinse it with a bit of water, get all the excess copper off the sides.
So
this is a picture of our setup. This is the copper sulfate solution. So this was CuSO4, and you can see the ion separately, CO2 plus and SO4 2 minus. We have 2.5 amps, which amps is just coulombs per second, which is what we started with down here. So we had this running for 1800 seconds, and just to get some more background on the experiment, we're doing this reaction. We're applying a current so that we're providing electrons to this solution right here, so that some of the Cu2 plus gains electrons and actually becomes copper solid that gets plated onto the key. So we can actually calculate the amount of copper solid that we created using some like Faraday's constant, which is 96,485 coulombs per 1 mole of electrons, and just doing some dimensional analysis. So knowing that we provided a current for 1800 seconds, and that the current is at 2.5 coulombs per second, we can cross out seconds, and then cross out coulombs using Faraday's constant to get moles of electrons, like total moles of electrons. Now from there, as we can see by this equation, there's 2 moles of electrons per 1 mole of copper, and then using the molar mass of copper, which is 63.5 grams, we calculate that there is approximately our theoretical yield is 1.48 grams of copper that is plated onto the key.
Alright, well here's our data table, and those are the masses of copper we found. And I don't know if it's right, so... Okay, so the problem with the lab was that our entire basis for those calculations for percent error was based off of the current, which we assumed would be 2.5, but our DC power sources are horrible, so they couldn't hold a current for more than 5 seconds, which means I had to do the calculations 3 times, and with a low value, medium value, and a high value. Low value I used 1.2, high value I used 3.5, we wanted 2.5, and then I did it out, and you can see that our values that we all got were much closer to the low value, but I actually think that what we were using was much lower than 1.2, like overall, for the 20 minutes because it's oscillating so much. So we ended up getting, for percent yield, like 30% for the people when we did it with a low value. So that's why I think it's actually lower than that. But that's why the percent yield is kind of obsolete because we don't know what current we were using. Do you have, where's your glasses,
No,
Will?
we didn't do gloves. Oh yeah,
We didn't do gloves.
Let's start over.
This
Is that 2.3?
Guys, why is this one green? Alright. So it's finally working, and we have a solid 10 minutes left of class.
They're bringing therapy dogs to the school.
When?
Really? I have a legitimate...
Where'd you fish?
But we still broke 5 brown trout. Yeah, but dude, it was the most trout I've ever seen in my entire life.